that many members have been asking for. It's about DStar. And for those of you who have heard of DStar, it is proprietary to ICOM. It is a digital communications mode. We now have some DStar repeaters in the area. And the two gentlemen that are going to be talking about DStar are actively involved with the purchase of and the getting the repeater up and running, and actually could tell you a whole lot more than I can about what DStar is. And just a quick step backward, the two gentlemen from RIT, they are the president and vice president of the K2GXT RIT Ham Radio Club. So there's a real good fit there, and we're looking forward to be able to have that interface with that ham club and to bring a whole new level of technology. And I think this is the first time we actually have a female on the board too. So things are moving ahead. So it's not the first time. Okay, very good. It's got to be the time I was in Michigan, and I don't remember. So Jack Armstrong's wife, maybe. K2J. There's a long time ago, yes. Okay, so getting on with the presentation. I'd like to introduce Gary Skuse and Michael Moore. Now, when I told people that Michael Moore would be addressing this group, I can't help it if they thought it was the film director. Now, I didn't correct them. At any rate, these gentlemen will be talking about DStar, and you don't want to listen to me, you want to listen to them. So I'll give you Gary and Mike.
So, hello everyone. I'm Mike Moore. This is Gary. And I'm Gary's flunky tonight, but I'm going to lead off. I would say that our interest in DStar came in 2008, I believe. Gary and I went to the Dayton Hamvention, and we talked to a group from Texas. They had a big system down there. And as I recall, it didn't sound that appealing to us.
Said it was pretty bad.
Yeah. But time moved forward. We always had an interest. We heard about the SCIARC group in Canandaigua. We heard that they had put on a repeater, and we thought we would pursue that interest. And here we are today, where we have a repeater. It's on the air. It's not completely connected, but we're working towards getting that connection. So that's how we started.
So the SCIARC guys, anybody here from SCIARC? Yeah, the SCIARC guys have been immensely helpful in helping us, because they did it first. But I'll also say that they were supposed to talk tonight, and I was looking forward to learning something by listening to them, and then they backed out, and Mike and I drew the short straws. So instead of them teaching us, we had to learn on our own the things that we're about to tell you. But the DStar system is interesting. We'll tell you about the features. We'll tell you about the trials and tribulations of getting one on the air. The other members of the crew are here, and we'll embarrass them when the time is appropriate. But we're just going to tell you a little bit about what DStar is, what we had to do to get it on the air, and then we'll invite you all to get involved. So let's see what we got.
That's kind of the Boy Scout method. We learned, we did, and now we teach.
Yeah. So DStar is the Digital Smart Technologies for Amateur Radio. It's not quite proprietary. It's an open platform. It was established in Japan by the Japanese Amateur Radio League, but it is sold in the United States solely by ICOM. So it appears to be proprietary, and it's not. And you can see that because there are other ways to access the DStar network besides buying an ICOM radio. There's a USB dongle called the DV dongle.
Yep, the DV dongle.
And then there's that other thing.
There's the hotspot. I think it's the DV hotspot, which is basically a DV dongle without a microphone and earphone. It's a DV dongle with radio.
Yeah. So there's other ways to do it.
DVAP, thank you.
Pardon me?
DVAP.
DVAP. Yes. DV access point. Is that what that is?
Yep.
So there's other ways to do it. What is proprietary is the codec. And these devices pay for the codec that they put inside of the device. And these radios have the same codec. They convert your analog speech to digital and then back again, transfer it through the network, both RF and the internet, and then convert it back to audio so that you can hear it. So that's what DStar is. And we are doing it in Fairport, and we are DCAP. We are the Digital Communications Association of Parenton. We formed the club forever ago, back in the early 90s, I think, and we were playing around with packet radio back then. So we've had a long interest in digital communications around Rochester, and several of the members here, like Charlie and Freddie and Mike and myself, and Jim was involved in the early days, we're having a lot of fun with packet. So it seemed like a natural sort of thing for us to get into DStar. Jim had the Flares. Where'd Jim move? Jim, you moved. The Flares repeater did, what was it called back then? iPhone, wasn't it? iPhone running on a computer in my basement over my dial-up connection a long time ago. So we've had a long interest in digital communications. And I want to again acknowledge the SciArc guys. I mean, they've really been instrumental. And if anyone thinks we're competing with them, that's exactly wrong. We're extending the network in Western New York. They've got things to the south of us, and we're trying to bring it up into Rochester. And again, they've been fantastic with helping us. Immensely difficult system to get on the air. And we needed I needed hand-holding, and I got a lot of razzing from Mike. So it was a big cooperative effort. You want to talk about the cost?
Yeah. It costs a lot.
Yeah.
We got interested in having a repeater because we heard that ICOM was offering a special deal. They were offering organizations that would put up a repeater in areas that they were interested in, and upstate New York is kind of a desert of DCAP operation.
DStar.
DStar, thank you very much. DStar operation. There's one in Buffalo, there's one in Niagara Falls. There might be one in Albany, but this whole area, there was nothing. So they were interested in getting some coverage in this area. So they offered a repeater that you would pay $3,000 for, and if you put it on the air and got it up and showed them that it worked, they'd give you that money back. So that's how Gary and I got interested. We did that, and then we both bought radios. Mm-hmm. The individual radios, the handheld that we have, this is a new model called the ID31. It's monoband DStar. It's what, $350?
Yeah, $380.
Yeah. Mobile.
I exaggerated. It's about $380, but $400.
A mobile, you'll pay just under $500 for the radio. So it's a pretty hefty price tag. Beyond the radio, it uses a regular antenna and in a mobile form factor, in a handheld form factor, and then the repeater site stuff, the antenna, the duplexer, and all of the other things you need with a repeater are the same as you would find with an analog repeater.
That's right. And these radios are pretty cool. The mobile radio has the ability to take a GPS input, and because it's all digital, it'll transmit your location. This radio has a GPS built into it. It also has a database of all the DStar repeaters in the U.S. or the world.
Yeah, you download it.
Download it. So you download a database. It takes your location from the GPS if you're traveling and tells you what repeaters are nearby. So, I mean, it's a really cool radio, but, I mean, it's a single band for $400. It's a little bit expensive.
But the important thing, which we're going to talk more about, it's much more than just a radio that I can talk to Gary and he can talk to me. The real power of this radio is the fact that it automatically links through the internet, and you can talk to people anywhere in the world because it's digital and the routing that this offers.
Right. It's a very, very smart system. So, and I just want to emphasize that, $3,300, you say, whoa, that's a lot of money. I got an invoice for $3,300. It went on my credit card. I had to deal with my wife. Okay? She is spectacular, but I said, I'm going to buy another radio. She goes, oh, yeah, okay. How much? Oh, I don't know, a little over $3,000. It's like, huh? So Mike was nice enough to split it with me.
And I was going to deal with her for you.
Yeah, you were, that's right. Mike actually introduced me to my wife years ago, so I don't know who owes who what. But Mike was good enough to split this with me, but I'll tell you, they gave us 90 days to get it on the air. And in order to get our money back, we had to take pictures of it at the site. We had to have a picture of the tower. We had to have it online so that they could go to this thing called the U.S. Trust Server. All DStar gateways, that's what the computer is called, all DStar gateways talk to this system. I think it's in Texas. They register, and all day long they're talking back and forth. ICOM checks to make sure your system is connected to it. So we had to fulfill all of these requirements within 90 days, and I'm sitting in work and I can hear the clock ticking. So we were highly motivated to get this thing on the air and to satisfy the requirements so we could get our money back. In fact, one of the happiest days in recent memory is when they said, sure, we just wrote you a check. And it's like, so even though the cost of admission is high, ICOM reimbursed us for it, so it didn't cost the club anything for the repeater, but I'll point out, we had to find a site, we had to have an antenna, we needed a duplexer. The radio itself, the RF deck, and I'll show you pictures of it, is essentially 2 ICOM mobile rigs inside a rack mount box. So the front end is as wide as can be. We have our repeater in a very, very good but RF-rich site. So we put it up and it didn't work real well until we put a filter in front of the receiver. All of the stuff we needed, including the people who are constantly contacting me saying, is it up yet? Is it up yet? So everyone had to be patient. So the cost was a lot higher than the $3,300. A lot of work went into this. And it wasn't just us. We put up the money, we got our money back. But Freddie and Charlie, who you'll see in the slides and in embarrassing situations in a few minutes, they helped with all of this other stuff, and we couldn't have done it without that.
To close on ICOM, you had the dealings with. They were great to deal with.
They were fantastic. Yeah. They were really fantastic. But, I mean, this is a hobby. $3,300 was a chunk of money, and it was a bit of a gamble. So I'm glad they were great. I'm glad we got it back, and it's actually fun now. So do you want to explain what this is? I drew this with PowerPoint.
Yeah, I don't think so.
No, I stole this from ICOM's website.
This is a schematic that you see quite often in the ICOM literature, and this graphically kind of explains the process. This is showing a ham with a handheld radio, and the radio takes in audio and puts out audio, but the codec and all of the digital electronics to convert the voice to data is inside the radio. So what leaves the radio sounds like a chainsaw.
Yeah.
It's a buzz. If we would transmit, and you would hear that on the analog radio. This depicts the signal going to a repeater site, or it could represent a gateway. There are standalone gateways. There's more than one way to get into the internet. And then through the addressing that the protocol provides, you can connect to another repeater or another radio. When you talk to another radio, that took me a while to get my arms around. You know, how does that work? Well, when you key up the microphone, it sends your location to a central server, and it can actually find you.
So if I understand correctly, and I don't, this is brand new to us. And Mike actually attended a course or a 3-hour class at Dayton this year. If you're traveling in Richmond, Virginia, and you get on the air and call me, will it find me? Or do we have to physically link first?
It's supposed to find you.
I think it's supposed to find me. Right.
He's got a key his radio in Virginia.
Right.
You know where he is.
Right. I think that's right. So they talk to all the gateways all over the country talk to each other. There's a website, you can actually go to Google and say something like DStar last heard, and there's a website that says on the KB2 VZS repeater, what's the last call sign it heard? It actually there's a central trust server in Texas that keeps track of who's where, essentially.
Yeah.
Kerchunking's encouraged. I'll tell you a really quick story. We put it up in the spring, and we had some work we had to do on it. We put it up again a couple weeks ago, and I was pulling out of my driveway the other day and just kerchunk it just to see if it could hear me. I kerchunk it, and somebody goes, oh, I see KA1NJL. It's like, wow, who's using the repeater? And it was one of the SciArc guys. And he had his radio on in his car. He heard the squelch break, and he looked down, and his radio displayed my call sign because my radio transmits it. And we had a great QSO. I mean, he went out to about Lima by the time I got to my destination.
Yes. I will say that originally it was designed for you to be able to find another ham wherever he is. In talking to the Atlanta guys that were in this course at Dayton, they don't really recommend that mode of operation because your signal goes through the other repeater without listening first. So they have rewritten some of the protocol to a more recommended style where if I knew you were in Phoenix, what I would do is get on the radio and connect to the Phoenix repeater, listen, and I would hear two repeaters where I'd hear Rochester and Phoenix, so I didn't step on somebody, and then call Gary in that manner. And that's, I think, the more gentlemanly style that's recommended now.
Right, so what we just said is this connection can take place automatically, or you can send a command from your radio that says, hook up to that radio over there. And that way you can hear the audio from that radio before you transmit. So it either does it automatically or you can do it manually or intentionally.
Yeah.
Does this allow you to connect to a echo link or something?
No. No.
Yes.
Yes. Mike took a course. How?
Well, it is like an echo link, but they're called reflectors. And it's this very similar kind of thing. A reflector is a computer that is someplace, and it really could be any place. There are probably 100 of them around the world. And it's like a big party line. If you listen to
It's like
the
one of those
London...
900 numbers that we used to call?
Kind of like that,
Yeah,
but
yeah.
almost. If you listen to a reflector, you'll hear people from all over the world. And typically the reflector has a flavor. So there are several Atlanta reflectors. There is a New York State reflector. One of the most common ones is the London reflector. That's going all the time. That's in England.
So
And-
can I rephrase this question? Will this connect to Echolink?
It
No.
won't, but it's something
But it's
like,
like it,
okay,
yeah,
if you've
that's-
got to be right, be right.
All
But
right,
I'm trying
all right.
to answer Van's question.
I'm not home. This is where I get to be right.
Exactly.
Yeah, so no, it doesn't interface with Echolink, but I'll tell you one of the projects that we have in mind that we don't know how to do. We also have an analog repeater that I've had in my basement since I bought it that's crystalled up for the same frequency. And I want to find a way to put both of them on the air from the same site. So if someone accesses it with an analog radio, they'll repeat, and if someone accesses it with a digital, they'll repeat. And I just don't have the smarts to do it. People around the world have done all sorts of really cool stuff. Once we get this working 100% with the internet connection, then we can think about enhancing it. But for now, and once we do that, then we can have an Echolink or an IRLP node or something attached. But right now it's got something like it, but it's not it.
One difference before we leave the Echolink idea, many of the reflectors are connected all the time.
Yeah.
You know, they don't just connect for a while and talk and then get off. Many repeaters and reflectors are always connected.
Storing, it's like having a server actually has the same data all over the darn country.
Yeah,
Yeah.
it's not like it. That's exactly what it is. There's computers somewhere that are just doing that, just letting them all link together so they can talk to each other.
So one goes down, the other one step in and take over.
Well, we have that too, but yes, that too. That they can link to various things, and that's dynamic. They can change that. So I got a short video that I stole from the ICOM website. I got to be honest about attributing where I get this stuff. Let's see how this works. I'd love to tell you I produced this on my laptop, but I took it from ICOM.
It was in 1901, more than a century ago, that Marconi succeeded in the world's first transatlantic radio telegraph communications. Even after that historic experiment, it has been radio amateurs that have been pioneering the advance in radio communications.
Need a pole.
Now, amateur radio is evolving into the digital communication era. Digital Smart Technology for Amateur Radio, or DStar, is a digitalized network amateur radio system which has been promoted by the Japan Amateur Radio League. It was born in Japan and started to expand worldwide. we are again opening the door to a new world. Let us introduce the DStar system to you. DStar allows simplex communication as well as communication through a repeater, as with analog amateur radio. DStar's most outstanding feature is the system optimization for the Internet. Yes, DStar allows you to access the Internet. When a transmission from a terminal radio reaches a DStar repeater, it will be relayed to a specified destination repeater through gateways according to the setting of the radio terminal. This station could be the next neighborhood, the next city, or even a different country. Since DStar uses the Internet, constant and stable communication is always possible, regardless of the distance between you and the other radio station. Such gateway relay DStar repeaters are already deployed in many countries, and the DStar network is growing rapidly. Now let us talk about the fantastic futuristic features of DStar. As mentioned, the Internet Gateway feature allows you to talk to stations virtually anywhere. The only requirements are a DStar compatible radio, a conventional antenna system, and the repeater equipment. Enjoy casual, local, or worldwide communications anytime. The crystal clear voice quality of the digital modulation is also the other attraction of DStar. Even distant overseas stations sound as if they are right next door. There is no annoying noise as with analog FM at the fringes of the communication range. In addition to the voice communications with the digital voice mode, serial text data can be sent simultaneously as slow data traffic. The data-dedicated digital data mode enables Ethernet-compatible 128 kbps data communication. Currently, DStar operators are enjoying the latest DStar application of GPS position data reporting. With a DStar radio and GPS receiver, you can see your position, exchange the information data with other stations, and see their position data on your radio display. Stations can be shown on a map on a PC screen when mapping software is used. The GPS feature will be a useful function to not only inform other stations, but for example, rescue teams if you get lost. Fast digital mode is compatible with the Internet protocol. Therefore, many current applications like web browsing and email can be used with DStar. DStar's limitless possibility of applications developed by amateur radio operators will further enhance the enjoyment of this system. For example, position reporting systems using Google Earth or chat rooms over the DStar network are some of the potential ideas that can be put into reality. As the DStar repeater system can be relatively easily installed, many amateur radio groups have installed and networked them by themselves already. There are various kinds of DStar repeater equipment components which can be selected according to the frequency ranges and operation modes the site operator wishes to do. Now for an introduction of some DStar compatible radios. The ID1 operates in the 1.2 GHz band with digital voice mode and fast data mode. The ICE2820 is a dual-band VHF and UHF digital voice mode mobile transceiver with the optional GPS unit to allow you the enjoyment of simultaneous position reporting. The ICE92D is a rugged submergible dual-band multifunction handheld transceiver. This radio also works with the optional HM175 GPS microphone for position reporting in places where only your feet can get you to. There are more DStar compatible radios, such as the top handy IC-B82 and the take anything and still keep going IC-2200H. An ample selection of radios to suit anyone's DStar lifestyle. Everything we know of is going digital. Despite being nearly a century old, amateur radio is no exception and an ageless leader of technology in any era. DStar was born for amateur radio operators and is being grown by amateur radio operators. As the history of radio communications has advanced because of amateur radio operators, we will continue to lead the evolution of DStar technology into the mainstream of the new era of radio communications. The time is already upon us when the phrase DStar equals amateur radio is no exaggeration. Video content supervised by the Japan Amateur Radio League. Production assisted by ICOM Incorporated.
Sounded a little bit like a script from a Japanese science fiction movie, didn't it? And the super fantastic radio. A couple things came to mind while I was watching that. One of them is you need to be careful if you choose to buy a DStar radio. They're called DStar compatible and DStar capable, or how do they distinguish between them?
I think one is ready.
Oh, and one's compatible.
The other one's compatible.
Compatible means you have to spend an extra couple $100 for the codec board. So the radio that they showed several times is a dual bander that had a display that looked like this, that displayed both bands. You got to buy the codec board for that, and by the time you're done, it's $700 or $800. The $500 mobile radios we have are dual band. The codec is built in, but they only display one band at a time, just like the old days. So that's one thing that came to mind. So if you buy a radio, be really careful that you really get a DStar radio, because you're going to be really pissed if you get it home and realize you got to spend another couple $100 to access the repeater. The other thing that came to mind is we told you that the club put up the money and bought the repeater and got it on the air. Some conditions that I forgot about. You ask for it, they send it to you pretty quickly. You have to be poised with a coordinated frequency, and you have to have a club call sign. So you don't just wake up on a Saturday and say, hey, I think I'll put up a DStar repeater. You've got to be ready for it when it arrives, and it takes time to do both of those things. We happen to be all set. That's one of the reasons our club could do it. Forgot to mention that
Some
before.
of the other things that were mentioned in the video, they talked about web browsing and email. That is true, but the web browsing and the speed that you need to actually carry on an internet-type browser application requires the gigahertz radios. The radios that we have are not capable of operating at that speed. But what they can do is all of the radios, the 2-meter radio as well as the 440 radio, has a side low-speed channel. And there is a program that's called DRATS that operates with these radios, and it's basically a keyboard-to-keyboard operation that they are touting for emergency communications work.
So kind of like old school packet radio, the same
Yes.
speeds as packet radio.
Yes, and the radios will do those simultaneously with carrying on the voice communication.
Yeah. So this is what a complete DStar repeater looks like. You have to own the controller. So no matter what you do with the RF side, you have to own the controller. The controller is the smarts. The controller connects to your computer, and the controller connects to all of the RF decks. We purchased a 440 RF deck. The guys at SciArc started out with 440. They also added a 2-meter deck. All of these are about $1,500 a piece, just to put this in perspective. So currently we have a controller, we have it connected to one RF deck. We have the potential to add more RF, and one of these 1.2 gigs is a data module that allows you to do the higher speed data from site to site.
One thing.
Yeah.
When you said high and low speed, what's
Yeah.
your low speed? 1,200 bucks?
Like that, Van, yes.
Yeah.
Something like that. Very low.
So it's a modular system. We started out with just a little bit. So again, the components, and this is something I've never done before. Fortunately, we had a club that had resources, and I don't know if anybody's ever been in Charlie's barn or his garage. It's kind of like a flea market. We bought the repeater, we bought the software, we needed a duplexer. Charlie happened to have a brand new one in the box. We needed a receive filter that Jim Stefano provided for us. Charlie provided the rack. Charlie provided the antenna. What did we do? The feed line was there. I had a router. I had a computer. We were good enough to get the site that has had it had a 2-meter repeater on for 20 years now, for a very, very long time. And then the internet connectivity turned out to be a challenge that we haven't solved exactly quite yet. And I'll tell you more about that near the end. But we needed all of this stuff. And let me tell you a little bit about installing the gateway software. Holy cow. It says in the manual that it used the CentOS Linux distribution, which I've installed Linux 100 times. It says it uses version 5.8. So I thought I was smart, and I downloaded 6.2, I think the latest one. It doesn't work, okay? I struggled with it. It needed libraries that were missing. I installed them. I teach a Unix course. And for the 60 or 70 hours I played with it, I'm telling myself, I know this. I know how to do it. I ended up installing 5.8. It just doesn't work. I went on the internet, I searched, and everyone says it doesn't work. And I said, no, I'm smarter than that. It doesn't work, okay? So this took a long time because I thought I could get it to work. And then once it's installed, the software is kind of weird. For example, you have to enter in MAC addresses for various things in this little network, in this box. And instead of separating them with colons like most people do, it separates the numbers in the different octets by dashes. So you cut and paste it, and it doesn't work. Then it asks for the IP address of the, I can't remember what I was looking for, the DNS, the machine doing DNS. This machine runs bin-D. This runs the DNS server itself. They say, what's the address of the DNS server? What it really means, and it took me 2 weeks to figure this out, what's the IP address of the port that the DNS server is plugged into in your router? Who would have figured that out, right? So this was a headache. This was a major pain in the butt. But we got it done. And the nice thing about having the club, Freddie was making jumper cables for us. Charlie was providing hardware from his store in his garage. And I was struggling in the basement with this. And then when it came time to put it all together, Mike and I spent some time in the basement, and we got it working. But major hassle. Not ready for prime time. And that's just not my opinion. Everyone who's done this has pretty much the same experience.
You did get some help from those people.
I got a lot of help. The guy who runs the US Trust server, this is one guy who runs the computer that coordinates the entire United States.
For DStar.
For DStar. Well, no, the other guy is Obama, right, that coordinates the entire United States, at least for now. So I emailed the guy, desperation, what's going on? I can't get this to work. He emailed me the same day and said, send me your config files, try this, do that, and he really helped me solve the problem. So just like in the ham radio spirit that we see all the time, even though this guy has a full-time job and another full-time job maintaining this server, he was great about answering my questions. This is what it looks like. This is on the back of my pickup truck. This is the RF deck. This is the 440 module. This is the control unit. And again, just for kicks, it has 2 USB ports on the front. The instructions say, connect your computer to port A, install this driver, make sure it works, connect it to port B, install a different driver, make sure it works. Software to work with these ports will be available in the future. Doesn't do anything, okay? But they're there. It's nice to have them. And the same thing up here. So we spent a lot of time configuring stuff that doesn't do anything yet. Or, there's some secret software that they haven't told us about. Vaporware, real soon now. This is the router, and I'll explain a little bit about the routing inside this box near the end. This is the duplexer, and then Mike provided a power supply that has enough beef to power everything in this rack.
And weld.
And weld.
And weld.
Yeah, it's just a lot of. That's a 35 amp power supply. And It's not real clear how much power this puts out. I think it's 25 watts. Again, ICOM doesn't tell you that. But this is it. So it's neat, it's self-contained, and it works. This is the tower. We're fortunate. I think, Jim, it's 180 foot, right? Because I seem to remember when Jim was installing a repeater a long time ago, he had 150 feet of hard line, and you got up and went, and there was still 30 feet of tower up there. This is a 180-foot tower. It's on Baker Hill. It's a great location, but it's an extremely RF-rich environment. This is our antenna, about 70 or 80 feet up, I think. We use some existing hard line. This is the antenna. And then this is a dish that I'll talk about later that's providing or will provide our internet connectivity. There is an internet feed at the site. We do not own it. And the people who do own it were reluctant to let us use it, which is okay. They own it. So we had to punt. And we decided to try an RF link from the tower to my house. It's line of sight about a couple miles. We don't have it working yet because we have to very carefully aim the two antennas at each other. So we need two guys up here. We need somebody on the tower, somebody on the ground with a laptop doing a signal strength measurement, and then the same thing back at my house. So we're almost there. It's going to require another trip up the tower. Did I miss anything?
No. I want to see Freddie on the tower.
We got that. This is the site. It's great. It's climate controlled. It's air conditioned and heated. Pardon me?
Mice and spiders.
Oh God, sorry about that. Lots of mice, lots of spiders. In fact, we took one of the spiders out the last time we were there, and I felt good about that. Right?
Yeah, Gary wanted to take the repeater out, and I asked him, well, what's my role here? And he says, you go in where the spiders are. And I came out with cobwebs over my face and went at him like that.
I don't like spiders. I don't mind mice. I don't like spiders. Okay, so here we go. We're getting this going. There was an isopole mounted at the site, at the point that we're using, and we ended up using the hard line that fed it. This is Freddie, KB2 GFZ. WB2, sorry. I say every Saturday morning we have breakfast, and I say that call multiple times while we're talking. If I had an HT in my hand, I probably could have said it right. I apologize. But he is our intrepid climber. I know from this position he just looks like an ass. And I say that because he's already done his work. No, he actually has to go back up. So this is Freddie. And I got that wrong. Son of a gun. I'll fix that. This is now installed in the site. And it looks just like it did on the truck, but just a little bit of a story. This is the computer sitting on top of it. And when we were installing it, we wanted to keep it off the concrete floor in case there was water, in case there was any issues like that. So we thought we were really smart, and we bought one of these $5 plastic tubs. And I'll say that differently in a moment. On top of this, while we were setting it up, we had an LCD monitor, a keyboard, and a mouse. Well, I'll now call this a collapsible plastic tub. We were standing outside the door, and all of a sudden, crash. And the first thing that I thought of was it took me 3 weeks to get this damn computer running, and now the hard drive fell about 6 feet onto the concrete. And it's like, But it worked. Came back to life, no sweat, lost a little plastic. Pardon? I'm sorry?
It'll work for a while.
Well, that's the rest of the story. So it fell. But, these are the things that happen when you put up a repeater and you do stuff for the first time. But when I saw that crash, it was like, a spinning hard drive hitting the concrete just really worried me.
And the LCD monitor survived.
It survived. Got a little bumped, but it survived. It was really, the things were going our way. So this is Charlie. He's the one who runs the store. And Jim came, and just another little story that went with us. Jim came to help us, and Freddie's up at 80 feet up the tower, and we're screaming back and forth. And Jim goes, come on, you guys, they're hams. Use a radio. So we sent a radio up to Freddie, and you weren't there at that time when we heard this.
I was not there at that time.
We heard a crash on the roof of this building. And it's like, first you look up, Freddie's still there, right? And then I think I yelled up and said, did you drop a wrench? And he goes, no. Jim's radio. And it was an unlucky radio. It was the second time it fell off a tower, right? Yeah. So it didn't survive. But he dropped a radio, so we learned in the future we scream, okay? Or we continue to use somebody else's radios, because Jim was good enough to fix it for him. But anyway, so Jim came and he helped, and it really takes a lot of ingenuity because we haven't done this before, and even figuring out how to mount the antenna on the tower in a stable fashion took a little bit of ingenuity. Did I miss anything? Hose clamps are okay. You know, it's cutting the Kindor, figuring out how to put it up so the thing didn't torque in the wind. I mean, I'm a biologist. So this is Mike. That's why he came. Mike was there to untie the rope.
That was for the lynching.
Yeah, that's right. That's for me the next time I go. We're actually tying spiders up with it. Okay, so the internet connectivity turned out to be a challenge. There isn't, for our purposes, there's no internet connectivity. It's a beautiful site. It's a great tower. It's climate controlled. It's wonderful. No connectivity. So our choices are to pay someone to run a DSL line and pay for it every month. We didn't want to do that. Pardon?
We're hams.
So we're going to use RF. We could pay monthly for something from Time Warner, but nobody wants to pay the cable company anything. We could do something cellular, or we use amateur radio ingenuity and we'd used RF. And that's what we're currently working on, and again, I'll have more to tell you about that. Do you want to tell them what we did?
Yeah, we used a set of Ethernet bridges, and these are basically wireless devices that, this is what, 5 gigahertz is our?
I think so, yeah.
5 gigahertz. And there are several different types of devices in this family. There's just a short monopole antenna all the way up to these dishes, and they're unlicensed, I hope.
They're essentially Linksys. They're essentially Linksys access points built into the feed horn. Excuse me. And you can see a signal strength meter right here, a bunch of LEDs, and this feed horn fits through the dish, and then the feed line comes in, or the Ethernet cable comes in from the back. It comes with a little transformer that connects to a power line, and it sends power up the Ethernet cable to power the access point. Lots of gain, like 25 dB of gain, and the beam width is relatively narrow.
Yeah.
So that's why we're going to have to spend a little time pointing at each other. But in theory, we need about 1 megabit a second to get all of the data that we need transferred, and this will do lots more than that, in theory.
Yeah, and these are fairly inexpensive. I think they're, what, $125 each?
Yeah, I'm the one who paid for them. They're $100 a piece, plus shipping.
Or free to me.
Free to you, that's right. And free for everyone else to use. But they were $100 a piece. I got them on Amazon, and they came 2 days later. You assemble them, and they're relatively easy to set up. We now have to align them and actually get the connectivity going. I made a big mistake. I was at my house. I have one connected at my house to my network. I have it on the side of the house pointing toward the hill. And I made notes about the IP address I assigned to this one and then the far one. So I connected it, and I went up to my computer and I started pinging it, and it was coming back with like sub-millisecond times, like, get lined up. Well, I got the wrong address.
There's a question.
Yeah, sorry.
Those are Ubiquity.
Yeah.
Okay, I'm familiar. I have a Ubiquity router at home.
Yeah, these are from Ubiquity. They make a whole line of stuff.
Except they don't make the home routers anymore. They just keep it down line, which is a shame because they're full 1 watt routers.
Yeah. Oh, that's probably why they don't make them anymore.
And the distance we're going to cover from the tower to Gary's house is about 3.5 miles.
Yeah, at most.
So it should work well.
Yeah. But I got all excited because I was pinging. I'm like, oh my God, I accidentally aligned them. This is great. And I had the wrong numbers. I had them switched. And then when I realized that, I was crestfallen again and figured, okay, Freddie's got to go back up on the tower. So these are the dishes. And the next, the thing that's good about what we did is it cost about $200. We get loads of speed. We got way more speed than we need. It's unshared, so we don't have to worry about anybody using our bandwidth. It exploits the otherwise unused bandwidth at the connection site. The connection site's at my house, right? My Roadrunner connection has lots of bandwidth that sits there idle most of the time while I'm here and while I'm at work. So this takes advantage of the fact that it's there. And we own it. If we had borrowed somebody else's, then we were at their mercy. If they wanted to disconnect it, if they wanted to throw us off, if they wanted to use more of the bandwidth and impinge on the stuff we needed, we were at their mercy. This way we have complete control over it. Doesn't work yet, but we have complete control over it.
Lovely.
Yeah. So, This is how the connectivity works. This I already revealed is my house. So up at the hill, I showed you a picture of the RF deck, the controller, the computer, and the router. And the way that this works is the RF deck is connected to the controller is connected to the computer is connected to the router, and what I didn't show, I'm missing a link, the controller is also connected to the router. So, no, I take it back. Controllers, no, I showed it right. The controller is connected to the computer has 2 ports. It has 2 networks. It has one network that talks to the controller and another one that talks to the router. The router does network address translation and talks to the rest of the world. So the world comes into the router talks to this. This controls both the outgoing and incoming traffic, and it mediates communications with the controller.
If you think about the picture that we showed with the little guy with the handheld and the tower and the globe, all of this is the tower part.
Right.
And
so this is on one of the this is on one of the buildings. No.
well, this is really shared functionality between your house and the building.
Right.
The internet is that globe, and we can talk to anywhere in the world from Gary's house, and then out here in the room are people with the little handhelds.
Right.
We talk to each other as well as to anyone else to whom we're connected over the internet.
Yeah. And this took a little while to set up, again, because the instructions that came with the software wasn't as clear. They weren't as clear as they could have been. But this all works fine. We have run into some other issues. The computer, of course, is one that we had laying around. We put this thing up on the hill. We tested it. Okay, I'll be honest with you. We took pictures of it and sent them to ICOM so we can get our money back. And then we brought it back so we could get everything working properly, and we had it in the attic of my garage. And this was a hot summer. The computer failed a couple of times because of the heat. So we're thinking about building another computer. And right now, the computer is still in the attic of my garage. Everything else is at the hill. That means the RF works just fine. I mean, we talk to each other through it all the time. We don't currently, as of today, have the internet connectivity. Once we get these lined up, we'll put the computer at the hill, and while we're thinking about building another computer that might be a little more reliable, something with a solid state drive, something that's less prone to having problems with temperatures. But right now, the plan is all of this goes at the hill. It speaks back to my house over those dishes you just saw. That goes into my home network that then goes out over the internet. One of the things that ICOM recommends is that the computer that runs the gateway has to be physically very close to the repeater. So the connection is a 6-foot Ethernet cable. It wouldn't work if we located the computer over here. There's too much latency, it just wouldn't work. The other thing we learned, well, we learned 2 lessons. I'm not good at making Ethernet cables.
I was going to say that. I've been laughing about that for a half hour.
I know. I'm not good at making Ethernet cables, which means when you put a bad cable in here, nothing works. The RF deck doesn't do a thing unless it's connected to the controller. We also learned that, okay, so I admit, I'm getting better at making cables. No, I admit I'm bad.
I recommend everyone get your cables from Home Depot.
Yeah. I actually bought some 6-foot cables at the dollar store for $1, and they work a little better than the ones that I made. But you get what you pay for. Those cost $1. The ones I made didn't cost anything. So these connect. The other thing we learned the very hard way is the back of the controller has a slew of ports. Remember, they were labeled, I think there was 4, and each RF deck, each frequency RF deck has to go into a specific port, and they don't tell you that. So the call signs that we use have a suffix that is a letter, and the letter designates what it is you're talking to. So 2 meters is a -A. Do I got that right? -C. 440 is a -B, and what's 1.2 must be A. Okay. So the back of this controller is expecting B to be plugged into the right hole, or it doesn't work properly. And we've screwed with that a lot, and then realized I had a bad cable. And then we screwed with it some more and got everything working just fine.
The radio, you mentioned the addressing of the radios. Programming a radio is not straightforward. The older radios are based upon the original plan for talking radio to radio, so you literally have to set up to talk from radio A, or that you think you want to set up to talk from radio A to radio B. It's somewhat cumbersome. There are two websites. There's dstarinfo.org and dstarusers.com, or they could be reversed. I mean, they're easy to find on the internet. And they have calculators that allow you to select the type of connection that you want, and it will download the parameters for your radio.
Yeah, so if I
there are a lot of aids for that.
Yeah, if I said KA1NJL wants to talk to KC2NM via the KB2VZS radio, it'll figure out how to write that parameter that gets loaded into your radio, because it's not straightforward.
It does take a little time to just get into their head and figure out what they want you to do.
Yeah. And another thing, if you're going to do it, these radios are programmable and they're very complex. I made an error. Mike programmed my radio twice, both my radios. And the problem with that is I don't know what's in my radio. So these do digital and analog, and if I want to talk through the 715 repeater, I'm not sure where it is, right? Because you programmed it. It's like in memory slot 412 or something. Very, very capable radios, very complex. I made the mistake of asking someone to set it up for me. At some point, I'm going to unprogram it, do it myself, just so I can learn it and become familiar with it. Thanks for the favor. Yeah.
You're welcome.
But they work.
Buddy.
We've talked to each other. We've talked to people. You've connected to other repeaters, distant repeaters, and you've talked over the internet.
Yeah, I've worked London and
Atlanta. Yeah, it's pretty cool.
What I really have not done that I want to do is I want to talk to my brother. And
Yeah.
if you loan me your radio, I'll be able to do that.
I know, we're going to do that. So anyways, so that's what it took. Took a little bit of gamble. You know, we had to pay the money and then we got it back. We had to find a whole lot of parts, and we were lucky enough to have somebody in the club with all of those. We were lucky enough to have a great repeater site. I mean, the site doesn't get any better. And it's working. The last thing we got to do is get the internet connection going. We anticipate that once we get Freddie back up on the tower, it's going to be trivial. The problem we ran into, like everybody else, this summer has been busy. Every weekend someone has had some commitment. There's been weddings and graduations and vacations. And now that the fall is here, well, we'll wait till it gets really cold. We'll have spare time and he can go back up on the tower. Pardon?
Wait for a hurricane to come up.
We could do that. I guess the winds get up to 100 miles an hour up there. Then it's time to do it. All right. Any questions? Yeah. John?
Can you send a text message right from the radio, or do you need a computer hooked up?
You can from the radio, but it's cumbersome. You got to spin the dial around and select the letters.
There's no keyboard. In fact, this radio has very few keys on it. It has
If you want to pick the call sign you're talking to, is it the same process, or do you have that pre-programmed already?
pre-programmed. That's easy to do with a computer. The software is free, right? But you have to buy the interface cable.
Right, except for, those are the older radios. Like Gary and I both had the IC880 and we had the ID31. The 31 is brand new, and the programming for that is much easier. Whereas in the ID880, you have to program every route that you want to access individually. The programming of the ID31 is a little more piecemeal. You have one field where you can say, I want to talk to this repeater, or you can say, GPS, find out where I am, pick me the nearest repeater, and it will do that. And then you switch fields and you twist that knob, and you enter the identifier of the reflector or the repeater that you want to talk to, or a call sign that you've programmed in. And then you key, and it makes that connection. One thing we didn't talk about is you make the connection one time, and then it's made. So you go back to, it's called local mode, where the other station's call sign is CQ, 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 CQ. So you connect one time, and you talk all day until you disconnect.
The other thing about these radios and programming them, there's a micro SD card in the side. So Mike picked this up for me when he was in Dayton. It arrived at my house. I met him at his house, and on the tailgate of my truck, he handed me his micro SD card. I put it in here. I dumped it into the radio's memory. I pulled it out, I put my SD card in, dumped it out to the SD card, and did the transfers just with the radios. So there's an SD card that I can read in my computer, I can program it in my computer, so I can program it without this radio, I can program without the interface cable, because I can dump everything onto the SD card and put it back in the radio. That's kind of cool.
All this is PC only, not Mac.
I don't know, is that true? I don't know about the, I've only tried it on my PC, so I don't know that.
I don't know the answer to that either.
Yeah.
I don't know.
Yeah. Do you have a question, man?
Yeah. What frequency is going to be on?
Right now, 444.8. Well, not right now, forever. I don't expect that to change.
Okay.
So it's there right now. Did I see another hand over here? Another question? Yeah.
I'm not sure I understand, but if you just hop on,
Yeah, if you haven't figured out, neither do we. We're still learning.
if he hops on and he wants to talk to you
Yeah.
specifically, he has to do some sort of...
Nah. No. It just, so in that mode, does that mode have a special name? Is that the local mode?
Well, you do have to program every contact on digital voice. Now, for example, if I want to talk to Gary at his, I mean, we can talk simplex. Obviously, that doesn't require anything other than putting in my call sign and calling, and the other call sign is CQ. The connections are call sign based, and there are also suffixes that you add to the call sign that tell the router how to go. For example, whenever we talk to the 440 machine, we're always talking on KB2 VZS B, because that's the B port. But if I want to call Gary on the local repeater, all I need to do is to put in my call sign, the repeater call sign and frequency, and then the destination call sign is CQ, 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 CQ. I can talk to anyone on that repeater.
Yeah, so all the radio needs to know is, I'm talking to the repeater. Then his radio knows he's talking to the repeater, and then we each talk to each other through the repeater. Okay? So that's why the other day, at the beginning of this talk, I said I simply kerchunked the repeater, and somebody came back to me. Because he saw, my radio is smart enough to know I'm talking to the VZS repeater on 440, on the B port. As soon as I kerchunked it, it transmitted my call sign. Someone's radio said, oh, Gary's on the air. He called me. All his radio knew was he was talking to the repeater.
So is there a special connection, or is there special information in your radio once you do a connection?
Well, I know his call sign and he knows mine, but that's transient, right? It displays it, but it doesn't remember it.
I transmit my call sign every time I make a transmission. And
Yours also says Mike. Yours also
and my
has your
name,
first name.
and you can also, I always put the radio type that I have in there. And that always goes out when I transmit. So for me to give my call sign is kind of superfluous because it's on everyone's display that is able to decode the signal. And all he has to do is listen to the repeater output. If I program my radio correctly, we'll be able to talk.
Can you talk between the two of you without the repeater?
Yes. Yes. There was a question in the back?
No, I'm K, he's W.
Oh, you're right. I corrected the wrong one. You're right. Right.
Isn't the radio basically for the system assigning you, I think it's like 4 IP addresses, one for like simplex and then for ABC?
Yes.
In essence, I mean,
You do that one time when you register.
so those are your unique.
That's a point well made. All that happens under the hood,
And
but
nobody
you do
sees that.
create that assignment, and that translation is made by the system.
It's a 172 address that the whole DStar system uses, 172 dot something else. And every radio, every gateway, everything connected to the network has a 172 address. And that's all routed within the repeater system.
Yes.
Yeah.
Well, also, if you don't have the repeater's call sign, but you just happen to hear one on the air, or you key up and you have the wrong repeater call sign, you won't be heard on the repeater, but if you kerchunk it, it will, the repeater will ID with its call
Right.
sign immediately thereafter.
And you can capture it. That's how I tested this on my HDR. I have a mobile rig that's not in my car yet. It's on a desk at home. Yeah, so if I just key up the repeater and I successfully key it up, it'll come back and display KB2VZS Fairport, New York. And then I know the call sign. So if I just transmit on a frequency and something comes back, I can display the call sign. And then I capture it and I can program it in and say, now talk to that repeater. Yeah.
With the repeater, is it similar to 2 meter where only one person can talk at a time? Or
Yeah.
Can you be on a reflector and then Mike can try and contact someone else?
Okay, that's two different questions. If we're speaking through the repeater, then it's just like a regular repeater, one at a time. Reflectors are more like you said, like a party line.
Yes, yes.
Right, but could he?
Because a reflector is a computer, it's not a radio.
Okay.
A radio, it's RF. You can only do one at a time. A reflector is a computer, so it can do more than one at a time.
The other thing that I had to think about is that the DStar system is advertised as a very narrow band system. So all of the bandwidth that's available is used just to carry that 48 kilobit voice signal. So it's not a situation where it can digitize that data and send it in a burst that is much shorter than the amount of time that it takes to transmit the voice. So I was hoping that two people can talk at the same time over the repeater, but you can't.
Yeah, each of you use half of the bandwidth, one going in each direction. It doesn't do that. Question back there.
I was just going to add, a system that can do that is Motorola's Moto Turbo, or also DMR, they're both the same thing. And those use time division multiplexing. There's 2 time slots. So when your radio is transmitting on, say, time slot 1, you send bursts every certain interval, and at the same time, somebody could be using time slot 2. And a lot of the ham repeaters actually do that. They use time slot 2 for talking, worldwide. Time slot 1 for local.
So the point that goes along with that is we had to make a serious commitment to put up a DStar repeater in terms of our time and money and everything else. And it was 2006 that we were in Dayton, and the guys from Texas had this massive display. And if you walk up to them and say, so how's it going with DStar? It's like, oh, geez, it's not that good. And it wasn't.
They were hungover, Gary.
They were hungover, as were we. But they, we had to make this decision. Do we want to do this with DStar, or do we want to hop on one of these other protocols? When Yaesu bought Motorola's, or is it the other way around? Well, in any event, when Yaesu started coming out with digital radios, it was new. And when DStar was new, nobody was using it. It took 10 years for it to sort of catch on. So we decided to go with this older technology because there were more of them around. There's new stuff coming out all the time. We made the decision to go with DStar partly because it's been around for a long time. Yeah.
Can you use this as an APRS radio also?
Well, it does. So this radio has a GPS built into it. Our mobile radios can take an external GPS and they will transmit your location.
There is a bridge from the DStar system in software that I'm sorry, what did you say, Charlie?
It goes to findyou.com.
Yeah, just like
There's a bridge
APRS.
from DStar to APRS.
But within the DStar network, it'll transmit your location. And then it ties into the regular APRS network through a bridge.
So if I'm on the APRS site, I get this call site, we'll put him on the map.
Yes.
The difference is I do not think, I guess I don't even know what I'm talking about, but I have not read that the DStar radios beacon.
They don't beacon.
It's only when you transmit.
Right. All you know is the last place I was when I transmitted. So that's different. It's not meant to replace APRS. It's meant so that we can find each other when we're talking to each other or want to talk to each other.
Essentially, it's acting like a
Mike E.
mic coder.
Yeah.
So you're only walking
When you key the mic.
at the beginning of the other event.
Just like a Mike E did, the tapper Mike E. Yeah, John.
You see a list of location, like distance and bearing to all the people you're talking to, or just the one you're talking to? And does it work simplex also without the repeater?
Don't know.
It doesn't work simplex. You can see the distance to the other person, and if you had a display to display it, you could see.
the radios have the display. No, it is on the HT. I think the answer to all of your questions is yes. It shows you the distance and bearing, and it keeps a list of who you've talked to.
But isn't that basic radio without DStars?
Well, in order to transmit the location, there's got to be digital something somewhere, right? And in the case of APRS, there's a modem that turns your analog or turns your digital signal in analog and then reverses it at the other end. This is digital straight through. There's no A to D or D to A anywhere. Well, in terms of the GPS. Well, even that's not true, but it's close to true. Okay, but you don't need a modem on each side of it. The A to D goes from my voice to digital and then from digital to my ear, but the GPS is all digital. Yeah.
Does anyone have the dongles or the access points and how they work?
No, I don't.
Oh, I've worked them, and they sound really good, and there's a lot of...
For 2 meters on the access point.
I'm sorry?
The access point, is it UHF or VHF?
Neither.
It is 2 meters. The DVAP that they have now is 2 meters, and then the dongle is not a radio device. It's a USB into the computer.
Right. That's strictly
you hear a lot of
TCP/IP.
them on the air.
Because they're relatively cheap. The dongle's $200, I think.
Yeah.
Yeah, so they're relatively cheap compared to a radio, but there's limitations, and you're not going to use it in your car.
There are some other things on the horizon out there. We saw them at Dayton. There are people that are making interfaces for radios that go into computers. There's a guy in the Northwest that's making a little brick that is actually a Linux computer and a 25-watt 440 radio set that you can run software for about 4 different things on there. So there are a lot of little things that are being planned for this.
Which is another good reason to grab something that's been around for 10 years, because people have been developing stuff to go with it.
You said something about emergency use. I don't see how it's going to be any good if the internet's down. What good is the system?
Well, because even on the RF side with no internet connection, you're going to transmit locations. So that goes totally RF.
Between an RF.
Right. Now, if I want to talk to Atlanta and the internet's down, I'm not going to talk to Atlanta. I'm going to use HF. Okay? So you're correct. Hey, there was something back there, yeah.
I wanted to find out what's the comparative signal-to-noise ratio, in other words, per watt, how far, you know, I can't go as
Yeah.
The digital has a little bit less range. But, like any other digital thing, with voice quality, all of a sudden you fall off.
Right. It's either there or it's not. The voice quality is very interesting. It's different. It's quiet. I mean, it's wicked quiet. So all you hear is voice. I mean, I know FM is too, but it sounds different. It's also the narrower bandwidth. When we were speaking last night, it sounded a little bit, I don't know how to describe it, but a little funny, because you could clearly hear that there's less bandwidth being used.
I'm old enough that my Elmer operated AM, and then I got into single sideband, and the difference is
Your
kinda-
Elmer invented AM.
the difference between those two. This is more like single sideband.
Yeah,
It's like listening to the narrow band on VHF.
it is. It is. Yeah, what is the bandwidth on these?
I think it's 7-ish.
Ish? Okay. But you know, it's 100% intelligible, and that's the point of communication.
Yes, kilohertz.
Yeah, kilohertz, megahertz.
One of the bragging points is it's half of what the commercial, what's that, the P25, Project 25, they advertise it's half of that.
So it's completely intelligible, completely, but the voice sounds a little bit funny. I can still tell it's Mike, no question about it, but it's just, you know, it's just not the same as an FM repeater, which isn't bad, it's just different. So if he transmitted on FM and he transmitted on DStar, it's called DV on there for digital voice, I could tell which is which.
Can you demo it? Can you reach the repeater?
Where's your, oh, you have it with you. Maybe, no, we can't reach the repeater from in here. Okay.
Did we?
The SciArc repeater? All right, so again, he programmed my radio. I don't know what memory location that's in. But we should be able to do simplex, right? So,
I think I programmed simplex in here.
so it's one of the memory channels?
I think.
Okay. Shit, I locked it. Any other questions while we're learning how to use these?
Yeah, let's do that after we close.
Yeah.
How about that, Mo?
Sounds good.
One of the things that they didn't say is that the club, while the club put in the effort to put it up there, feel free to use it.
Oh, that's a good point. Yeah, someone emailed me, it's like, we use your repeater, and I said, it's not my repeater. We put it up for absolutely everybody, so absolutely use it. Absolutely. That's why it's up. That's a good point. Because a couple of people asked me, and I said, yeah, of course you can use it. Yeah. Oh, you're the one who emailed me this week. Yeah, computer's down. Computer's down. As soon as it's up, you're welcome to use it. You can use the voice without registering. You can just use it. The register. So if you want to use the repeater, if you want to use the gateway portion of it, which means going out over the internet, you need to register. In ICOM, so again, I talked a little bit about how the ICOM software is kludgy. If you go to our club's website, there's a link that says something like repeaters. You go to that, it says register on our DStar gateway. You click that, you get a warning page that says security certificate not valid, blah, blah, blah. That's the way they gave it to us. I asked everybody, and everybody says, yeah, we can't fix that. That's just the way it is. So you click through that, you trust us, then you register. Oh, cool. Is this mine? I didn't know it did that. Okay. So I know, it truly is. You register on it, and that allows you to use the gateway function to get you to other radios. But just to use it to talk over the repeater, just like a standard repeater, you don't have to register.
AA1NJL, AA1NJL, 58P2NM.
So I was going to make a comment about you're supposed to use the lowest power necessary, so we could use audio frequency. Okay, go ahead.
AA1NJL, AA1NJL.
Godzilla.
KC2NM. This is NOAA.
So, yeah, that's right. So what it says here is KC2NM, and even, did you hear the enunciator? It actually said that when he unkeyed. But it says KC2NM, Mike Rochester, and he also put in that he's using an ID31, the radio. So all of that displayed at the bottom of my display after he unkeyed his mic. And I assume mine's working too.
Yes, and we don't have the echo if we're not in the same room.
That's true. Yeah, this is artificial.
What is the input?
444.8.
No, it's 5 up.
Oh, it's 5 up. 449.8.
Okay.
Sorry. Yeah, and an analog radio is not going to do anything whatsoever. An analog radio will not key the repeater.
If you listen on 441.0, you can hear the chainsaw.
So why don't you do it? 441.0 is simplex. Got it? Got it?
And BNE,
This is the Texas Chainsaw Massacre.
Okay. Mike, transmit. Now, if anybody can copy really fast Baudot or no, you probably get that. Oops. Thank you. Any other questions? Yeah.
Is ICOM still offering that rebate?
No. So this was something. So we've been watching this for years, right? And they did it a while ago. In fact, the SciArc guys. Do you guys remember when you did it? Was it a year ago or?
About a year ago.
Yeah. So they did it, and we heard SciArc did it. And it's like, damn, missed our opportunity. Then they did it again in January. And so they do it periodically. But the application process is a little bit tricky. You've got to convince them that you're in an area that they're interested in. You know, why should we give you a repeater? You've got to have a club call. You've got to have a coordinated frequency. You've got to have a site. You've got to tell them where the site is. I mean, you really got to be ready to rock and roll when you apply. And then 2 weeks later, they say, okay, we granted this. Here's a shipping, a tracking number. And the next thing you know, it shows up. So you got to be ready to hit the road. Then the clock's ticking. From the minute they ship it, your 90 days is ticking. And it's
They sort of tell you that they won't do another one within 100 miles.
Right. But then we talked them out of it.
We talked them out of it.
Right. Right.
You have to also show proof that you had like, what, 15 people to,
So,
2 people to sign.
yeah. So to get your money back, 10 people. To get your money back, 10 people had to register on our gateway. But of course, there's ways of doing it. You call every ham you've ever met. You just say, please register. It doesn't matter where they live. As long as, and then you have to take a screenshot of 10 people registered and send it to ICOM. Yeah.
Car with DSL 3816 has blocked me in and I want to go.
Is that somebody's car?
DSL 3816 is license plate.
I think we have a winner.
I want out.
Any other, it is getting late. Any other questions? So I'll repeat what Charlie said. We really, really invite you to use this. Get a radio and take advantage of it. It's kind of fun. I mean, it's something new. You know, it's kind of fun. And if anybody wants to put a 2-meter repeater on the air, hand us the module and we'll wire it in. Other questions? I know, really. Any others? All right, well, thank you.
Thank you, guys.
When are you going to get your DXCC?
Yeah, really, on this. I'll tell you, it's really a thrill. I mean, it's like the very early days of IRLP and such. You know, you key it up and you're talking to someone in another country from an HT. It's like, wow, this is cool. So it is cool. Thanks. Let me, so. So Mike, how do I get back to the